right, so that's what we're talking about. All right, electrons bonding and structures, or structure of atomic particles. Well, it's all around us. When we look at substances, they may look very simple. Let's take salt, for instance. It does not very, it does not look very pleasant or interesting, obviously. But within that grain of salt, spectacular things happening. These are clear and have a certain level of truth for all substances. For example, cloth may design not to crease. You see, it can be designed not to crease at all. For example, dusters that attract more dust extremely. For instance, the bike frames. Okay, now typically, even the water we drink, they all possess an extravagant and precise bonding and structures within their frame. Everyone may in one or other ways, experience some of the physical effects of chemical bonding. Other point, an example, typical example, for skating on ice, or some insects skate on the surface of water. You may have some questions in mind that what makes such effect takes place. The remarkable effects of type of bonding referred to as bonding coal, hydrogen bonding. When we use a metal plate to cook our food, we can then start thinking of metallic bonding, because the fact that food heats up, also because without the heat will not be conducted through the pan. And that bears the question of electrons. Electrons play part in all the above mentioned processes. The reasons are that because of electrons, that the elements we know about can do or do nothing at all. Because electrons involved makes things happen. We could, however, perceive the whole chemistry as a race to try to lose or gain electrons. So in the interim, we will learn about subatomic world of electrons and how they influence bonding within molecules. You see, we have seen another terminology called molecules and the structures that substances adopt. Well, don't be moved by all this, terminologies. But I think we are going to look at all these terminologies in details when it comes to the influence of structure of atoms and the bonding involved. Now, within that same space of arena, we are going to look at shells and orbitals. Okay, shells and orbitals. What will be our purpose? We should be able to demonstrate and apply our knowledge and understanding of the following. A, the number of electrons that can fill the first four shells of the element. B, the atomic orbitals, including X, the region around the nucleus that can hold up to 2 electrons with opposite spins. Y, the shape of S and P orbitals. Z, the number of orbitals making up S orbitals. P and d orbitals or subshells, and the number of electrons that can fill the s, p, and d subshells. Then after that, we will look and break it down to energy levels, where we will expatiate it from the norm. We will look at the Aufbau mechanic principle. Then we'll look at Hund's rule of multiplicity. Then we'll look at the degeneracy. These rules will help us to be able to understand the position and the spin of electrons in all individual orbitals and suborbitals. Well, without bothering with so much words, let us go back to the text. And you can, these days, you have your mobile phone to take shots of the note, or you can do your own research in the library, or you can go online and play around it, and that will give you more knowledge, understanding of the topic, electrons, bonding, and atomic structure. Okay, so this is what we have. You take your time, by the time we meet next time, you have read a lot, and it will make the understanding so easier for everybody. Yeah? So that is what we have for today. I'm going to leave you guys to go and do more research about this topic. Then we'll break it down further. Without further ado, I'll say goodbye till we meet again. Bye.